So I got a question about if you get a product from the customer and they want you to copy it, or if you just want to put it back on the table to do some additional machining like chamfers or stuff. I'm gonna show you how to do that. So I purposely put it quite crooked here. So PCCAM is amazing. It comes with a bunch of features. I'm just gonna go and orient place the probe here around there maybe, and then we're gonna go into there and we're gonna do basing, and then we're gonna select bottom left there, that thing. We got basing on 2 points. We don't want that now because we also want to catch the rotation. If we only wanted to find our 0 location, I'm gonna turn off the music here so you can hear me. Looks very pretty though. So let's see, that looks good. So we're not gonna have basing on 2 points, we're gonna have 4 points. The first offset we can't have 10 because this thing has one of these thingamajiggas. So let's go with, I don't know, 25 and 100 in the horizontal. That's gonna be this 100. We could easily go 250 because that looks like it's like 300-400, and that could be 100, I'm sure. Let's just try it. I'm gonna do the search corner thing, and maybe we should do the measurement distance like 35 since it's in a notch like that. So I'm gonna do that. It's gonna go, and first, okay, didn't want to do that. Why did it not want to do that? Measurement depth, yeah, we can't have 5 because that's gonna go into the table. So we're gonna do, I don't know, 2, and then gonna search corner. It went back to where it was, so right now it's gonna go down, it's gonna measure the top surface, and then we're gonna move to the side and touch up there, and then we're gonna go 250 or whatever we chose, capturing the angle of it. Failure. That's annoying. So 40 would have been enough. Search corner. Yeah, let's try that again. So top surface, our first point in the horizontal axis, the X. That's mighty crooked. Yes, it is. And then there, bam. And then we're gonna go there, bump. That way, we now have our probed position. We're gonna do the set basing data, and yeah, you can get some information about the coordinates and whatnot. But we can go ahead and close this. And here's our pace. Nothing has changed. It just looks the same, right? Yeah, that's because our toolpath there. Let's just do let's see, outer loop 3. This is 3mm, create, bam. So you see there, it's gonna cut everything. But if we go into that G code and we click this use basing data, let me show you. So when I click that, it goes from this to this. You see the difference? It tilts the entire machine, it looks like. But it's, of course, the piece itself that's crooked. So we're ready to go. That means right now we could just work on this. We could add a chamfer all around it. It's gonna be pretty awesome. Sometimes though, you have a really wonky shape, so there's no perpendicular lines to measure. So what do? Luckily, yet again, we have a solution for that. I say we, but I mean Kimla. So we have 2 holes in the mirror here. If we select those, right click and then select insert markers of every selected object. Bam, there you go. So now what we do, we go back to cam, and then we go to the probing screen. We're gonna do basing, and then we're gonna select this inside diameter thing. You could, you know, set the whole diameter something more correctly than, you know, 50. It's gonna be, I don't know, 8. Doesn't really matter though. And then what you want to do is you gotta jog into the hole there. This is quite difficult to do without my second hand. And to be able to probe into the hole, we're gonna have to turn off the production of material. Yes. And there, and all I did there was jog down. It automatically stops and reverts up, I don't know, a millimeter or something. So that we can see that the ball is focused. Yeah, well, it's in there anyway. So let's see. We could do search hole, but before we do that, we have to select this marker. So that's the plus there. You can't do plus key here. I'm still running the old version of PCCAM. I'll tell you all about the new version later. But anyway, just press the green plus button there. And then that's gonna say, focus, one marker selected, right? So great. And now when we run search hole, it's gonna do a little dance. And it's gonna be done. So that's really quick. And all you need to do is to set basing data. And now you're gonna probe the second hole, the right one. And when doing that, make sure you select this first and plus the plus key. And when it's done, press the set basing data. That's gonna take those two values, and thereby it's gonna know where it is on the table, and it's not gonna know the orientation of it as well. And that works remarkably well. Of course, it kind of should, because on this machine we have linear motors, and therefore we have the digital scales, crazy resolution, crazy accuracy. And also this is a Renishaw LP2, so the repeatability is like 1 micron. Crazy. So I have flipped full sheets, and well, if I work on this surface first, then I clean cut this edge so that when I flip it and I push against the stop pins, then it's going to be referencing a nice cut edge. The only thing is you want to be careful when you do that cut, because if you go full depth with a small tool, there's going to be a tiny bit of tool deflection, so that when you flip it over and push it against there, it might be a few hundredths or even 1/10 of a millimeter off. But if you go like slower, so that you don't have too much tool deflection, then it's going to be flippity spot on. And if you're doing chamfers or countersunk screws, that's going to work just fine, no problems whatsoever, even full sheets. That's crazy. Temperature changes affect this more, I'd say. Anyway, so that's the way you do the thing where you put a piece on the table and you find it so that you can keep working on it. There's going to be more videos about other features, and there's going to be a new video about, you know, the general overview and editing of the geometry, just because the other one is so outdated. But anyway, talk to you soon. Bye bye.